Okay, so this chapter is all about probability, and the first two sections are really pretty straightforward. There's not a spot for this in your notes, but this part should make sense. Basically, an impossible event has a 0% chance of happening. If it's certain to occur, it's 100%, and all other probability is in between. So probability always has to be in between 0 and 1. So remember, 100% as a decimal equals 1. All right. So then here's just some terminology. With experimental probability, you repeat an experiment over and over. So the number of times you repeat that is called the trials. The number of trials is just the total number of times. The outcomes are all the different things, all the different results that you can see happening. Like if you flip a coin, you'll either see heads or tails. Frequency is just the number of times that it's observed. And the relative frequency is the frequency, the outcome expressed as a fraction out of the total number of trials. Okay? And when we talk about experimental probability, it's just your relative frequency. So you think about when you flip a coin, it's 50% chance that it's going to be heads and 50% tails, right? But it doesn't mean every time it's going to be heads, then tails, then heads, then tails. It's just if you flip it a whole bunch of times, you probably are going to have about half heads and half tails, but it's not perfect. That's why we call it experimental probability. You are basing it on several different trials. All right, so this table shows the number of short-term visitors coming to Australia during this period of time. Estimate the probability that a person who visits in June is on holiday. So here is June. Here is the holiday. So what we're going to do for letter A is just calculate. There were 156,500 that visited in June on holiday. And this is out of all the total in June. So this is the total number of June people. So in June, this was how many were on the holiday. And then you want to approximate that to 3 sig figs on a decimal. So just divide that. So that's just over 50%, 0.508. Letter B, estimate the probability that the person who came to Australia in this total time period arrived in May. So first of all, we need a total. How many total came to Australia? And that ends up being 890,700. Here, let me put this down here. Out of the total who visited, how many came in May? So this was May. Out of the total who visited, and then divide to get your decimal, 3 sig figs. Always make sure you're doing 3 sig figs. Okay. Lars arrived in either April, May, or June, so that sounds pretty goofy. What's the probability that he arrived in April? All right. So he's visiting his brother. So this is the visiting friends or relatives. So first, if we add all of these up, the total visiting friends is 190,100, and estimate the probability he arrived in April. And then we're going to estimate this to 3 sig figs, 0.408. So it's just reading tables and finding the probability of success over your total. And that is all A is. B is just a way to organize your data into a two-way table. And it's two-way tables compare categorical. So different types of categories. For example, this one's talking about transportation and gender. Okay. All right, so let's look at this example. So people exiting a new ride at the theme park were asked whether they liked or disliked the ride. The results are shown. Now, I think one thing that's helpful when you get done, when you're given a two-way chart like this, figure out totals. All right. So how many children rode the ride altogether? That's 72. How many adults rode the ride altogether? 58. Out of all the people that liked the ride, 83 liked the ride. How many disliked the ride? So a lot of times you'll see the totals on the ends. And then if we add up, there were 130 total. That should match both ways. Otherwise you did your math wrong. So always check that. I have a little bit more room, so I'm going to actually write it this way. Probability liked the ride. So it's always helpful to indicate what exactly you're finding. So I'm just going to put P of this. All right, so how many liked the ride? Total, 83 liked the ride out of 130 total. And make sure you're using your approximately. So approximately 63.8% or 0.638 liked the ride. Now notice in B and C, the words and or. All right, so we have to pay close attention. Probability, child, and disliked. So they're a child and they disliked. So that notice that there's 17 children who disliked the ride. So 17 out of 130. And then round it to your nearest 3 sig figs. All right, probability adult or disliked. Okay, so think about how we would do this. They have to be an adult. So how many adults? We have 58 total. Or they could dislike it. Okay, how many other disliked it? So these were all the adults, but we also have to include the children that disliked it, because they could be an adult or they disliked. Out of the total, 130. So then we're going to add these up. So typically when you see the word or, you're going to add them together. So we have 75 out of 130, which is approximately, and that's the end of the notes.